In this video, we're going to talk about matrices. So we say one matrix or two or more matrices. And what a matrix is, it's a rectangular array, or you could say it's a table. It's really good at storing information. And one of the things it's used for is solving systems of equations. So we'll explore that idea of solving systems of equations as we move through chapter 16. So let's see some examples of matrices. We almost always call matrices by capital letter names. So we've got matrix A here, and we can talk about the size of a matrix. So let's make a definition. We'll say that the size is the number of rows times the number of columns. So if we look at how many rows A has, it's got 2 rows, it's got 3 columns. So we would say that A is 2 by 3. So you always reference the number of rows first and then the number of columns. So in a similar way, we would look at B and we would say, well, matrix B over here also 2 by 3. And our third matrix here, matrix C, that's 3 by 2, 3 rows and 2 columns. So the first example that we're going to practice is just a little bit of algebra. We'll see how to add matrices together, subtract them, and how to multiply them by a real number. So I've just recopied the 3 matrices that we had on the previous page, and we're going to find a few different things. So part A, what we're going to do is the sum A plus B. So to add 2 matrices together means just add the corresponding entries. So for example, you'd look at the 2 numbers that you've got in the upper left of your matrix and you just add those together. So 1 plus 1 is 2. Then you'd move to the next position here. So the entry in the top row, middle column, 4 and -1, add those together. That gives you 3. And so what you can imagine is you could imagine the matrix A just sliding right on top of matrix B, and then you'd just be adding together the entries that would land on top of each other. So the 9 and the 6 would get added, get 15. And then for the bottom row, you'd go 2 plus 2 is 4. 6 plus 1 is 7, and then 0 plus 1 is 1. So that's what it means to add 2 matrices together. Now another operation that you can do with matrices is you can multiply any matrix by a real number, and that will not change the size of the matrix. So if matrix B was 2 by 3, when we multiply B by any real number, still going to be 2 by 3. If we want to multiply B by -2, then we're just going to go through, multiply every single number, every single entry in B by -2. So we'd go 1 times -2 is -2, -1 times -2 is 2, etc. So just multiplying each and every entry within B by -2. We'd have -12, and then in the bottom row, we'd have -4, -2, -2. So just as a check on the signs, if we look back at our matrix B, originally there was just one negative number in B. And then when we multiply B by -2, there should just be now one positive number in the new matrix. So that looks good. So for part C, let's try something a little more interesting. We're going to do 2A minus 6B. So think of this as meaning 2A plus minus 6B. And let's do this multiplication first. This is called scalar multiplication, when we take a matrix and we just multiply it by a number. So let's multiply everything in A by 2. We'd get 2, 8, 18, 4, 12, 0. And then to that, we're going to be adding on -6B. Okay, so let's multiply everything in B by -6. We have -6, positive 6, -36, -12, -6, -6. Okay, so that's our scalar multiplications done, and then it's just a matter of adding those 2 matrices together. So adding the corresponding entries, we'd have -4, 14, -18, -8, 6, and -6. So part D, we're going to do one last example here with these matrices. So let's say we want to find A plus C. Well, A plus C is going to be undefined. And the reason is that A and C have different sizes. So when two matrices have different sizes, you're not going to be able to add them or subtract them. And that's why our discussion of size was important. A is a 2 by 3 matrix, whereas C is 3 by 2. So it does not make sense to add those two matrices together. So we're going to do one last example where we solve for x and y. We're told that these two matrices are equal. So the idea is that when you have two matrices that are equal, all the entries in the matrix must be equal. So that should allow us to solve for x and y. Okay, so let's just confirm. Entries in the top right, they're equal. Entries in the bottom left are equal. Yep, so we're good there. And then it must be true that x plus 3 is equal to 9. So that tells us that x must equal 6. And then if we look at the bottom right, y minus 2 must equal negative 7. So that means y must equal negative 5. And that way we're able to solve for both x and y. Same idea here, we want to solve for x and y. Now in this situation, it's impossible. Because if we look at the second entry of the matrix, these guys are not equal. So there's no way, there's no value of x that's going to make these two matrices equal. And we just say, no, the problem's impossible. So again, the problem here is to solve for x and y. We have another impossible situation. Two matrices can only be equal if their sizes are equal. So if you say that differently, if their sizes are not the same, then there's no way that those two matrices are going to be equal. So there are no values of x and y out there that are going to make these two matrices equal to one another. So that's a short introduction to matrices, and we'll explore them further throughout Chapter 16 and use them to solve systems of equations. Thanks for watching.